Hello everybody, I would like to show you in this video how to obtain uniform variables and normal variables by using Excel. Okay, in this column, these are the numbers of the data. So I have 1000 data. Here I have random variables. These are all random variables. I obtain 1000 random variables. This is a very simple function, random function in Excel. It calculates the random variables between 0 and 1. When we are doing the Monte Carlo type of calculations, it's the random variables that we use if you're using an Excel. Just extra information, just a tips. And I calculate the means and the standard deviations associated to it. And I will talk about the normals and standard normals a little later on. Okay, uniform variables. Uniform variables supposed to be produced by this random variable. If you looked at this graph, well, if you highlight it, and if you ask Excel what type of graph represents the best for this type of data, it has some options. So this is the data points that we would like to see. The x-axis are the indexes of the data, and the y-axis is giving to the data points for us. So we choose that one, and it gives us to this graph. What this graph represents is the data points of your uniform variables, which are the random variables obtained by the function in Excel, which are the random. So when we are talking about the uniform variables, on the picture, the visualization in our mind should be this picture, similar to this picture, but we want a really perfectly uniformed distributed data points, which means that there is no empty spaces and it should be no clusters like here. We don't have a perfect random function. It is produced by computers up to now. Well, people are talking about the artificial intelligence, and there are some people just claim actually how to obtain the random variables, but this is a big subject, how to obtain the random variables by using the computer. And as you see in Excel, even the 1000 is a large number of the data that you are playing with. You will not be able to get a perfect uniform distribution in the plane. Okay, these ones is a random, which means that if I calculate the data again, it will reproduce the points for me. If I go to the formulas, and you see there are calculations option here, and you see here calculate now. As you see, it will change. Right? The shortcut for this is the F9, the function F9. If you press the F9 key, if you are working in Windows environment, F9 key. If you're working in Apple environment, you need to press, or Surface Pro environment, you need to press function, then F9. For each F9, for each calculation, Excel produces a new random variables for me. Let's have a look. See, in this case, I have empty space here, empty space here. When we are talking about the uniform, it should be everywhere is uniformly distributed. So that is an error term in the calculations already there. Okay, that's a tip point here. That is a uniform variables. Right? That is a definition of the uniform variables. So when we are looking at the bins, the frequencies of this data, okay, how we obtain and how it looks like. So here is the increment, and these are the bins for me. So since we have the numbers, random variables changes from 0 to 1. So I'm just going to divide the 0, 1 into, say, how many intervals? 21 intervals, 20 intervals, 21 endpoints, right? And each interval is increased by 0.05. That's what it is. And then this column here calculates the number of the data which are smaller than this number. So this is a counting function in Excel, calculates these variables, 1,000 of them, looks at the 1,000 of them, and calculates how many of them is smaller than 0.1. As in the previous video that I showed you, in order to be able to calculate the number of the data points falls into a certain interval, I need to subtract from the previous data, right? So here, if I subtract from here to here, I will find exactly the number of the data point it falls into that interval. So in this interval, I have 59 points, right? In this interval, I have 49 points and so on. With this calculation, we are supposed to get a flat view of the frequency graph. Here, actually, all these histograms should be ending in the 50%. Since our production of the random variables is not really giving us the uniform distribution, we wouldn't obtain that. Right? In some cases, if you calculate, you will have a better approximation to the uniform distribution. In some of them, you will not. In average, it is still around 50%. So it will do the job eventually, but not perfectly. We'll do the job eventually, but not perfectly. Let's put it that way. Okay, this is the uniform distribution. In order to be able to obtain normal variables, right? I also have another video about the normal variables and standard normal variables and uniform distribution in terms of the theoretical sense. And please watch that one if you have questions. Okay, what we have here, in the normal variables is the normal inverse of the random variable, right? This is how you obtain the normal variables. It will give you, so these are the normal variables appearing here. And we are going to look at the frequency table, and I will say something about it. But these are as a data points. This is how we obtain normal variables by using the norm inverse function. Let's have a look what this function says. That is the inverse of the normal cumulative distribution with the specified mean and a standard deviation. So I want to 0 mean and 1 standard deviation, which will be easier to understand. So I choose those ones. Okay, that's the normal distribution. And this graph shows you how the normal distribution looks like in terms of the plain data, right? That's what it is. Right, these are the points, 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 points. As you see, the tendency is in the middle, right? We have most of frequencies is happening in around 0 because the 0 is our mean. Look at the differences. Here, uniform distribution, the data set varies all over your plane, right? From 0, 1, from 0, 1, that's the square that you have. That varies there. But when we looked at the normal distribution, the data points, it tends to squeeze in. The clusters around the mean. That is the normal distribution. Normal distribution, the most frequent data appearing around mean, right? That is the normal distribution data. Okay, that's the one thing that I want to say. Second thing that I want to do is to obtain frequency table. So I choose the increment 0.4, and since this is this normal distribution varies between 0 and 1, sorry, the normal distribution with the 0 mean and a standard deviation 1. So if you looked at the end points, you will have -3 sigma, +3 sigma in the end points. So it is reasonable to think about -4 to +1. plus 4. So these are the corresponding to far ends of the normal distribution. This is why it's chosen as minus 4 and plus 4. And as here, we've done a couple of times, we are calculating the number of the data less than this number. And then this calculation shows us the number of the data which are falling into that place, falling into that interval. So in this interval, I have 2. In this interval, I have 13, and so on. So to see how the frequencies works, that is the frequency data, frequency graph of the normal distribution, as we expected, right? This is an almost given. If you looked at the histogram, that is a normal distribution, which is symmetric around the mean. I have these corresponding to mean numbers. This is why I have this. But this is the frequency. This is the 0 appears around here. That is the mean of the data that we have. And -1 + 1 -2, 3 + 3. And here the end, as we see, this is -4 case, and this is the +4 case. You can change actually by looking, you can change to the x-axis by choosing to select data, and then you have edit. So you can give these numbers. We need a little bigger number. As you see, the numbers will appear if you make it big enough to see what's happening. This is +4 here, this is -4 here, and it looks like a normal distribution. A little bit of a small number here which appears as, again, since we are producing the random variables by itself, if I ask to the Excel recalculate again, it will give me another shape. And some of the shapes are much more closer. For example, this one is closer to the normal distribution shape than the others, right? So this is how we obtain the normal distribution and how it looks like in practical way. These are the random variables distributed by the uniform variables that's distributed by the normal variables. That's all for this tutorial. Thank you very much for listening.